Now, a step up for this method, and I talk about this a lot more detail in my psych testing class, is the factor analytic method. Now, this is a cool, fancy statistical technique that I love, and I recognize as well beyond the scope of this class. However, factor analysis was a key, essential aspect of personality from a historic standpoint. There's a reason that the major model we're going to cover is the 5-factor model, because it was developed using this technique. So what you do is you have lots of people take all these questions and then you analyze them with factor analysis, and you see which questions clump together. Because people who score highly on one question that's all in the same construct will score highly in other questions tapping that construct. It won't be perfect, but they'll move in the same direction. And the basic idea for factor analysis is you identify which questions, which items group together. Let's say we're measuring cat lovingness. If you say you love your cat on a scale of 1 to 5, like you say, yeah, 5, I super love my cat. And then there's another question that's like, do you let your cat sleep in your bed, or something like that? And most people who love their cat, like at a 5 level, are also going to be like, yeah, I totally let my cat sleep in my bed, or things like that. So like your level of catness on one thing, also likely to be scoring a 5 is a cat lover, or loving your specific cat. And this holds for all things, like all personality items. And like, you'll see this in your test too. Students who do well on one question of a test tend to also score well on the other questions on the test. And you can get multiple clusters, which is not something you tend to see on like tests for like classes, but for personality and other inventories that have multiple scales, what they do is they have lots of questions and they see which clump together. So how do you develop a test using this technique? What you do is the following. You generate a long list of objective questions, things that could be on your test. Then you administer those items to tons of people, tons of them. So you administer these items to like a large number of people. Should be, oh sorry, my camera is blocking my note. So they should be from the same group of people that you would want to take the test. Like, don't go into an old age home if you're interested in understanding kindergartner personality. Just from an age standpoint, so you want the same people who you expect to take the test to, like, use the test. Because those items will most likely work. Because you don't want to have to generalize right off the bat. So what you do is you consider what items that group together have in common and name that factor. So naming the factor is honestly one of the hardest parts for me of factor analysis, because there are some really good factor names out there. And then there are what I come up with. So here is one example, because you're not given the name. You may go in kind of knowing what theory you want to work in, and that's how you generate your list. But you read through all the questions that cluster together and decide. So here, what do these items have in common? In most ways, my life is close to ideal. You've likely seen this survey. The conditions of my life are excellent. I am satisfied with my life. So far, I've gotten the important things I want in my life. If I could live my life over, I would change almost nothing. And people who answer in the affirmative and score highly, so if it's a 1 out of 5 scale, they say 5s and 4s on all of these. All those similar responses are driven by an underlying construct. Here, because we're not in a classroom setting, I will tell you what the factor name is according to the people who developed the scale. And unfortunately, it is blocked on my screen, so excuse me. It's the Satisfaction with Life scale. Ed Diener and a couple other folks made this scale in 1985. Now, if I were to have named this scale, I would see which individual question is most strongly associated, which has the biggest correlation. And that's the name. So here, it would be the in most ways my life is close to ideal factor. The close to ideal factor would probably be what I would end up with. Which is okay. It saves me the agony of trying to think of a good way to capture all of them. It is lazy. But I can at least do it systematically, because I do not have the gift that Ed Diener does. He's a great guy, and he has magical skills with factor naming that I do not. So, there are some limitations to this method. The quality of information from factor analysis is limited by the quality of items. If you do not have a question about a part of the whatever you're trying to measure in the pool, the factor analytic technique isn't going to know you missed some, or that some parts of a construct are overrepresented and others are just left out. That's why we make a really big pool and try and be really broad. So it can be difficult and subjective to decide how the items that cluster together are conceptually related. They don't always make sense. So what factor analysis does is tells you how things cluster together. Or not how, it just tells you like what stuff clusters. It doesn't tell you why. It could be a third variable, similar to how correlation doesn't equal causation in the research method section. That's the same case with factor analysis. So it could be that they all are related to something else. Like maybe there's SES is the true driving factor, and SES is related to low SES is related to higher levels of stress and lower levels of education. And so you may get a cluster that's like stress and education. It's only clustered together because of something related to SES that you didn't measure. So it doesn't tell you what the conceptual reason is. And sometimes it's not even related to what you were hoping it would measure. It's capturing something else that moves together, but isn't what you wanted. And so what it's effective for is it reduces a pre-existing list to an essential few traits. It allows you to refine a test that already exists. So finding ways to eliminate weird questions, or seeing if what you theorize from a test actually cluster together. I use factor analysis to extract constructs from items that exist from really old tests that didn't have this technique. Factor analysis used to be really computationally expensive. Back in the 50s or 40s, an entire dissertation is the final step in a grad program to get your PhD. That one factor analysis could be it. And that would take a year to do really in depth. A year would be awesome, you're badass. To put some context, for my dissertation, I ran a lot of factor analyses. I had 1.01 million factor analyses in my dissertation. 1.01 million. It took 2.5 weeks to run. And that includes simulating all the data. 2 weeks to do 1 million of them, while it used to take a year to do one. It's amazing how far we've come. I'm sorry, I can't help but we're going to talk about this little technique a bit, and it'll come up again. So this is a foundation for a lot of other statistical methods, structure equation modeling. It's really similar for the chemistry folks in the class, on the internet, on the Zoom. PCA, so principal components analysis, which is a common method in chemistry to see how can we reduce our stuff into the fewest number of components. It's close. There's debate by quantitative psychologists on exactly how they're related, but they're similar. So that's the same idea. Okay, we're almost done, I swear.